It's weird because our universe is not just expanding, it's not just enormous and empty and wonderful and curiosity inducing and just like kind of gobsmackingly cool in all ways. It's also super weird because our universe is kind of filled with magic numbers.
Well, then how did it? Right. Let's go into the big question that everybody always wonders. Right. So then, how did it get here?
Yeah, we do know a lot about that. In fact, that's one of the great successes of modern science, right? Is the fact that we do know a very large amount of the history of the universe with a few kind of key gaps along the way that we're filling in now. And eventually you go all the way back closer and closer to something known as t=0, the beginning of the universe. Everything had to have at some point had to have been packed into a tiny dense little point that then started to expand. And we can go in that we actually know quite well about our universe from now way, way, way back to when the universe was about, I guess, 10 to the power minus, I don't know, minus 15 seconds old, 10 to the power minus 20 seconds old, something like that. So if you have 0.000, 25 zeros and then a 1, that number of seconds. But that's not enough for us, right? As physicists, we're like, okay, well, what was before that? What happened before 10 to the power minus 15? That's basically what we do. When you build enormous machines like the Large Hadron Collider, what you're doing is when you build a larger machine of higher energy, you're actually looking farther back in time. However, if you then ask the question, which I think is kind of what you're asking, what was before that?
Like, where did all this stuff come from? Right.
Where did it all come from? Exactly. That's a huge open question. That is an open question for science. We do not have an answer for that. We have a lot of really fascinating kind of edge of knowledge speculation about where this kind of universe could have come from. Because at the end of the day, it's also related to a question that I think about a lot. It's weird because our universe is not just expanding, it's not just enormous and empty and wonderful and curiosity inducing and just like kind of gobsmackingly cool in all ways. It's also super weird because our universe is kind of filled with magic numbers. What I mean is that there are constants of nature that are just kind of numbers that are put there that we measure, that we have no particular way to explain why those numbers are what they are. So I'll give you an example. In our equations for gravity, there's always this G factor, which is something we just measure. It's like it's nothing that comes from a theory. So why is that number the way it is? There's no explanation. There's no mechanism. And physicists, we love mechanisms. That's what we're looking for. It's like it's not enough. So some people are like, okay, maybe the reason we have these particular numbers, these magic numbers in our universe, maybe the reason is that our universe is actually nothing special. And in fact, these numbers could be something on a very large range of values. In fact, a nearly infinite range of values of that number. And in fact, all of these other values, in fact, do exist as the correct values in other universes in a multiverse. But that's kind of an end run around the question, what was before the Big Bang?
So this is a safe space here. What is your most outlandish theory?
Most physicists, we're totally obsessed with outlandish theories. We are trying desperately to find answers to these questions that have been sometimes open questions for like 100 years. However, there is one theory that's not mine that I find fascinating from a kind of philosophical and also scientific perspective. Our universe seems to follow certain kinds of mathematics really, really, really well. So it starts to make us think that maybe humans did not invent mathematics. Maybe humans discovered mathematics. Maybe mathematics is the actual underpinnings of everything around us in existence. Maybe our universe is secretly made of math, secretly fundamentally made of math.
So I'm guessing that a part of that potential theory that's not worked out right yet would be like, well, how can the universe be made up of something that doesn't physically exist?
Well, that's exactly. You're asking a really key philosophical question here. What does it mean for something to physically exist?
Oh, crap.
When you get down to such a small level, this thing called quantum physics takes over. And quantum physics has a very profoundly different way of treating what stuff is at the smallest possible scale. So an electron is not best modeled as a chunk of something moving through space. It's actually best modeled as a little kind of wobbly packet of probability. And it's actually like a little wave packet, something that's sort of vibrating constantly. So once you do that, you end up with this thing that's like a little wave packet moving through the universe. You then start asking questions. In fact, you not just asking questions, part of the mathematics of quantum physics, they indicate that there's a lot of things about the universe at the smallest possible scales that are not intuitive to you and I. It's like we talked about earlier. We evolved in this very kind of friendly conditions, and that's not the way that the universe works at the smallest possible scales.